All right, guys, here we go. Pre-calculus, chapter 9, section 2. Homework page is going to be on 622. And so in 9.1, we're just talking about generic sequences, okay? But what we want to talk about in this section is very specific, okay? It's going to be arithmetic sequences and partial sums. So we want to find terms and sums of arithmetic. So arithmetic's the key here. Arithmetic series are some sequences or a pattern of numbers that add by the same value over and over to get to the next term. Okay, so you start with a term and you add the same amount every single time to get from one term to the next. Okay, so an arithmetic sequence has a common difference. So there's an equation that you have to remember. AN equals A1. That's a 1 right there. Plus n minus 1 times D. All right, so you have to memorize that formula right there. And so this formula, if you isolate A1, there it is. A1 is AN minus n minus 1D. Or you can isolate D. You can take the difference, find the difference. Find the difference by doing AN minus A1 over n minus 1. So this formula can be written different ways. And the sum formulas, the sum of as many terms as you want. Different books have different formulas for this, but I like this one the best, okay? The sum of n terms is going to be n over 2, 2a1, plus n minus 1 times d in parentheses. This will give you the sum of as many terms as you want. Okay, so let's do some examples. All right, so let's say, for example, I have a sequence here, negative 12, negative 1, 10, and let's see, 21, like this. Okay, now technically, this is called a series. No big deal. When we use commas, it's called a sequence. When we use pluses and minuses, it's called a series, but they're interchangeable, so don't worry about it. All right, so what we want to be able to do is find any term we want. Let's say we want to find the 20th term. Okay, find A20. We want to find the 20th number. So you have to memorize the formula. Okay, AN equals A1, parentheses n minus 1, D. Okay, so the 20th term will be the first term, n minus 1, D. So my first term here is this guy right there. That's A1. So negative 12 plus, okay, n minus 1. N in this case is 20 minus 1 and D. You have to find out what D is. What is it that we're adding each time? Not subtracting, okay? Think about this. What is it going from one term to the next? How much are we adding each time? Okay, so D in this case, if you count it, right, it's going up by 11. So the 20th term is going to be negative 12 plus 19 times 11. Okay, so just calculate that out. 20th term will be, let's see here, negative 12 plus 209. So 20th term we're looking at is, let's see here, 197. That's it. The 20th number down the road will be 197. Okay? So we can do this for any term at all. Pick a random spot, okay? A 43rd, okay? Just a random number, okay? This says find the 43rd number for me. No big deal. The 43rd number, okay? So it's going to be negative 12 plus parentheses 43 minus 1 D, which is 11. Okay, A43 is negative 12 plus 42 times 11. So 43rd is negative 12 plus, okay, 462. Okay, so now the 43rd number is 450. There it is. Now, they might get fancy with you, okay? They might give you a problem where, hey, for example, they might say, for this sequence, which term, okay, is 384. All right, see? So down the road, you're gonna reach this number, okay? Looking at this pattern, -12, -1, 10, 21, on and on and on. Down the road, you're gonna find this number, okay? Now, what location is that? Which term? That's the question. Which term is 384? That's the question. All right. So now, what location is going to be 384? So the thing you need to know about n is going to be positive, right? Doesn't make sense for the location to be negative. And also, n is going to be a whole number. Okay. So when you're looking for this spot, location wise, it has to be a positive and a whole number when you're looking for it. So this is not too bad. Again, you're going to use the same formula. an equals a1 plus n minus 1 d. Okay. The only difference is now, okay, we don't know what n is. We know the term, we know the first term, we know d, but we don't know n, so no big deal. We're going to go find out what n is. A n, which is right here, this guy. Okay, so we're going to substitute 384 right here. So 384 equals -12, right, first term, plus n minus 1 d. Unfortunately, we don't know what n is, okay, so we can't put anything there. But we know d. D is actually 11. Okay, so 384 equals -12 plus n minus 1 times 11. Okay, so up to you how you want to do this, but I would recommend distributing here. 384 equals -12 plus 11n minus 11. Combine like terms, right? 384 equals -23 plus 11n. Bring this over. Okay, so we're looking at 407 equals 11n. So divide by 11. So n comes out to be 37. Okay, there you go. So what this says is that the 37th term, A37, is 384. That's what we just found. Okay, so this is going to be the tricky part, okay, of the problem. So make sure you're able to do that. Now, the next type of problem is going to be, again, same idea, same example, -12, -1, 10, 21, on and on. Okay, we want to use Sn equals n over 2, 2a1, n minus 1, d. Okay, this is called the sum formula. All right, so we want to know what happens when we add all of these up. Okay, there's a bunch of numbers here in this pattern. It never ends. But for example, let's say 3, okay? S3 means take the first 3 numbers and add them. S3, really simple. S3 is going to be the first 3 numbers, -12. We want to add this with -1. We want to add 10. What happens when I add up these 3 numbers? S3, that's what S3 means. So adding these up, I get -3. Okay, that's all. S5, okay? I see all 5 numbers here. What happens when I add them all up? -12 plus -1 plus 10 plus 21, and the next number is going to be 32. Okay, so if I add these up, Okay, add it all up. I'm gonna get here, let's see, I'm gonna get here 50. S5 equals 50. Okay, that's just me manually adding these. Okay, so negative 13. If I add 10, I get negative 3. That's 18 plus 32 is 50. So I can add manually, but this formula would be a better idea for me, okay? I can get the same answer by doing S5, 5 over 2, 2A1, so 2 times negative 12, plus 5 minus 1 times 11, which is D. So S5, I can do it manually, or I can do this formula. It makes it easier for me, okay? Negative 24 plus, this is 4 times 11, so 44. So here S5 equals 5 over 2 and 20. Okay, so cross cancel there, I get 50. And that's it. So I can do any sum I want, you know, randomly. So for example, for this pattern, I want to do a number like, I don't know, S23, okay? S23. This says take the first 23 numbers, okay, starting with negative 12, negative 1, 10, 21, on. I want the first 23 numbers and add them up. Of course, I don't want to write them all out and do it manually, so I want to use a formula. It says 23 over 2. 2 times first term, 2 times A1, plus 23 minus 1, okay, times D, okay? So 23 over 2, it's a decimal if I divide that. So I'm just going to leave it alone for a moment. I'm going to, hopefully, this will cancel out. So I get here negative 24 plus, this is 22 times 11. So this is going to be plus, okay, 242. So 23 over 2. Okay, when I add this, it's going to be 218. Okay, so just now maybe I need a calculator then. Okay, so when I multiply that out, I'm going to get 2,507. That's my S23. Now, the next level up of this type of question, again, is they're going to give you a kind of a tricky problem a little bit. They're going to say for negative 12, negative 1, 10, 21, on, okay? They're going to say, hey, add these up. But S of how much, okay, S how much will be 1,292. How many numbers do I have to add up to give me 1,292? Okay, so again, use the formula Sn, n over 2, 2a1, n minus 1, d. Okay, so this is the sum, but we want to know how many numbers did it take to get this. Now, again, when you're looking for n has to be positive, okay? And n has to be whole. Think about the question. How many numbers does it take to give me this total, right? It doesn't make sense to say a negative number. It doesn't say it makes sense to be a decimal, okay? So what you're looking for is n has to be positive and whole. So we're going to use this formula and plug in everything we know. The only thing we don't know is n. We know the s, we know the sum. So 1,292 goes on the left-hand side. N I don't know. N I don't know. So I'm going to leave it at n over 2. Now, what's 2a1? 2 times negative 12. Again, I don't know n, so I can't put anything there. Times 11. So 1,292 equals n over 2, negative 24 plus 11n minus 11. So simplifying this part, I get 1,292 n over 2. Okay. I get here 11n minus 35. Okay, so what I'm going to do is my yin and my yang. That's a go. Yin, I'm going to take the denominator. I'm going to multiply over here to the left-hand side. So 2,584. My yang, I'm going to take a numerator, distribute n. 11n squared minus 35n. Okay, so now this comes to be a quadratic formula. So 11n squared minus 35n minus 2,584 equals 0. Okay, so now here's big quadratic equation. You can quadratic formula it. You try to factor it. Okay. I would recommend, if it's not so visible, then do quadratic formula, right? Quadratic formula is opposite of b plus or minus square root b squared minus 4ac over 2a. Okay, so let's try it. So opposite of b is 35 plus or minus square root 35 squared, negative 35 squared, no big deal, minus 4 times a times c, negative 2,584, all over 2 times 11. Okay, so we get here 35 plus or minus 1,225 plus, right, negative 4 times 11 times negative 2,584. So that gives us 113,696. Remember, it's all over 22. Okay, so I'm going to continue over here. 35 plus or minus square root. Okay, I'm going to add these two numbers in the middle together. I get here 114, 9, 21, and 22. This should be a perfect square, I'm hoping. Okay, let's see. Yep, so 35 plus or minus, the square root of this is going to be 339 over 22. So I have two answers here, 35 plus 339 over 22. And the other one is 35 minus 339 over 22. Okay, so adding these, I'm going to get here 374 divided by 22. My answer here is 17. First answer is 17. Okay, my second answer is going to be negative 304 divided by 22. It's going to be negative 13.81, repeating. Okay, so this answer is no good at all, because two things. One, it's negative, and two, it's not a whole number. So we're looking for the positive whole number. That means it took 17 numbers to get this grand total of 1,292. Okay, so good luck on that. I hope you understood that. All right, bye-bye.